Hopefully you've had a chance to try this problem on your own. I'm going to walk through the solutions now. And it's asking what is the wavelength of light that's emitted when we have an electron that relaxes from the n equals 4 to the n equals 2 energy level. So we want to identify this wavelength in nanometers and describe the color of light it represents. And so hopefully this is in the visible range. So starting with this, I'm going to take my, try to decide what my N final is and my N initial. And so that final one is where I end up. And so that's always going to be the lower value of my two quantum number N's that I'm comparing. So my final N is going to be 2 because it's relaxing from 4 down to 2. And my initial then will be 4. And so I want to know what wavelength is. So the equation I'm going to use is that one I had on the previous lecture, that we have Planck's constant times speed of light divided by wavelength gives us the energy of a photon. So that energy of the photon is going to correspond to the opposite of the change in energy between the two energy levels. And so we can characterize that as 2.18 times 10 to the negative 18th joules times 1 over quantum number n final squared minus 1 over n initial squared. So the goal, again, is to get to that wavelength, right? And so I'm going to plug in here my 2, and at my initial, my 4. My speed of light is 3.00 times 10 to the 8th meters per second, and my Planck's constant is at 6.626 times 10 to the negative 18th joules. So I'm going to write this all out in a way that solves for lambda. So, or sorry, wavelength. So my wavelength is going to be equal to that Planck's constant times my speed of light divided by this 2.18 times 10 to the negative 18th joules, not joule seconds. That's Planck's constant. I messed up my units, sorry. Times this 1 over 4 squared minus 1 over 2 squared. Oh, sorry, mix those up. 1 over 2 squared minus 1 over 4 squared. All right, so plugging this into a calculator is a mission in and of itself. Please get familiar with your calculator and reach out if you have questions about it, especially with this number of values that have exponents. So plugging this into my calculator, so try this on your own and then make sure you get the same thing as me. I get a value that is 4.86 times 10 to the negative 7th meters. Now I need to convert this, that meters comes from the use of meters in the speed of light. And so I need to convert this into nanometers right here. So that way I can think about this in terms of the visible light spectrum or beyond it. So that's times 10 to the 9th nanometers for every 1 meter, which gives me a value of 486 nanometers. Now I can compare that to my visible spectrum, which goes from about 400 to 700, where the 400 end is violet and the 700 end is red. And so this value is going to correspond to blue light.